Okay, we've got to the point where we've got a binomial distribution with n is 10 and p is 0.75, and we wanted to know the probability of getting 5 or more. We said that was the probability of 5, plus 6, plus 7, plus 8, plus 9, plus 10. It's a lot of work. We don't want to do a lot of work. We want an easier way of doing it. I said we can use the tables. And in these green tables, you will find different sections. Now we want the bit where n is 10. And if you look in the tables, each of these things here has a different n number. And I'm on page 11, and I can find a section which is headed up n is 10. And for the question I was dealing with you, we have our p-value being 0.75. And if you go along that n is 10 row, you will find a p-value of 0.75. So that identifies this column of numbers here are going to help me answer this question. We all managed to find the right bit in the tables. Okay? These tables are less than or equal to tables. So that's really important that you grasp. The tables give you the probability that x is less than or equal to something. They are yours to keep. Yes, they are yours to keep. Okay. Identical tables can also be found in the back of your textbooks, but the ones you get in the exam are these green ones, and it just stops you having to swap the back of your book all the time if you're doing questions. If I give you these other ones, but yeah, they're yours to keep. So, greater than or equal to 5 was what our question was. But these tables are always less than or equal to tables. Can you think of a probability I can put in here? Basically, what number I could write in here? And I may have to do some other fiddle with it as well. But what's another way of saying greater than or equal to 5? What's the opposite of greater than or equal to 5? Less than or equal to 4. So those two things are opposites. They're not equal at the moment. I've got to do something else here. If they're opposites, yeah, 1 minus, that's right. Okay, I can do a 1 minus because they're opposites. So being bigger or equal to 5 is exactly the opposite of less than or equal to 4. And there's nothing I've missed out, because 4 is included in this bit, 5 is included in that bit. Because they're opposites, I can do a 1 minus. So if I look in the tables for the row that corresponds to 4, so what I'm going to do now is I'm going to line my bit of paper up with the 4 row. I mean, the n is 10 tables, the p is 0.75, that number there is 0.0197. So this x is less than or equal to 4 is 0.0197. So if I do 1 minus that number, I will get the probability that I actually wanted. And if you do that taking away, you get 0.9803. And that is the answer to that question. So rather than work out on the calculator the probability of 5, end of 6, end of 7, end of 8, end of 9, end of 10, and add them all together, you can use these tables. And they do save time. You happy with that bit? Right, in part A, we wanted the probability that x equaled, what was it in part A? X equaled in part A 8, wasn't it? Okay. You could have used these tables for that as well. That is not the same thing. What I've written down there, so I zoom in, is 8 and everything less than 8. What can I remove from there so I'm just left with 8? This is counting 0, 1, 2, 3, 4, 5, 6, 7, 8. I just want to count 8. Yeah. If you do that, this is 0, 1, 2, 3, 4, 5, 6, 7, 8. This is 0, 1, 2, 3, 4, 5, 6, 7. So if I take all of that lot away from this lot, I'm just left with the 8 one. So in the tables again, in that same column, if you go down and find your 8 number, the 8 number I'm getting is 0.7560. 0.7560. If I've read that right. The 7 number I'm getting as, what's anybody else got the 7 number to be? 4744. And if you do taking away with those two numbers, well, earlier we got an answer of 2816. And if you just do that and check, so we got 0.2816 from calculating. If you do that taking away, we get 0.2816. So you can use these tables an awful lot. And that was part A. In part B was the probability of getting 8 or more. X is greater than or equal to 8. We can't deal with greater than or equal to's. We've got to turn it round so there's a probability with a less than in there. Can anybody tell me what this will be over here? What's the opposite of greater than or equal to 8? Go on, Lucy.
No.
You were right. The opposite of more, 8 or more is or less. Yeah. So put a 7 in there, less than or equal to 7. And because it's an opposite, what do I need to put in here? 1 minus, yes. Okay. So for part B, which we worked out earlier, we could have just gone to our tables and found our 7 number, which we said a minute ago was 4744. And do 1 minus that. Now a minute ago we worked out that that one was 0.5256. And if you do that taking away there, you do get the same thing. So you can use these tables as well as doing all the calculations. They're there to speed up time. Really they are there for when calculators couldn't do factorials. If you remember, factorials get very, very big very quickly. Your calculator can't cope with anything bigger than 69 factorial. Before they had scientific calculators 20 years ago, doing this on a calculator would have been virtually impossible, some of these sums. So these tables were printed out and people used them. That's where we're going to stop today. We'll carry on next time.